Hello. Today we're discussing characteristics of quadratic functions. Our objective for this lesson is to explore the properties of parabolas, find a maximum and minimum values of a quadratic function, graph the quadratic function using their x-intercepts, and solve real-life problems. Okay, so really we're just going to look at the one parent function, the parent function f of x equals x squared, our quadratic parent function, and all its different children, all its different possible children, reflections, translations, stretches and shrinks, and talk about them and their characteristics. Okay, so first, let's go back to our last lesson and remember our function, our quadratic in our translated form. Okay, our vertex form of our quadratic. F of x equals a, x minus h squared plus k. Okay, if you remember from our class discussion, the vertex of this is hk. So the vertex of this quadratic occurs at the point h. Again, remember that negative h and that k, because that works backwards. So our vertex is at the point hk. So this ordered pair right here, this vertex on our graph, would be at hk if we were in this form. This a out front, again remember, determines whether this thing does what we call opens up or down. That a determines whether it opens up or down. Okay. Hey, what's interesting about a parabola is that it has what we call symmetry. Okay, meaning I can cut this in half down the middle, and the one half will be the same on the other half. So let's mark that line cutting it down the middle. So I'm going to mark that here. So this line right here going down the middle actually divides it into two equal pieces, or that if I was to fold it on that line, it would lay on itself. Okay, so a parabola is symmetric. This line is what we call the axis of symmetry. So the axis of symmetry is this line. So the axis of symmetry is a line, okay, that divides the parabola. Okay, into mirror images. Okay, and if you notice, this line actually goes through the vertex. So my axis of symmetry always goes through the vertex. Okay, and since it's a line, we can write the equation of this line. So the equation of this line, again, in this case it's a vertical line. The equation of this vertical line, if you notice, it crosses the x-axis. Okay, and it crosses, in this case, it crosses the x-axis over here at h, because this is the coordinate h. So we're over h, up k. That's why we have hk. So it's over h. So the equation of this axis of symmetry is always going to be x equals h. And again, remember, it's the equation of that vertical line. Okay, it's always going to be that x equals h. Okay. Okay. All right. So here in example 1, it says to graph that function. Okay. Label the vertex and axis of symmetry. So again, remember, this is my parent function, again, is my x squared. So my x squared is my parent function. F of x equals x squared. So it's going to be parabola. Okay. Remember from our previous section how transformations work. So this plus 4 is going to move it up 4. And this plus 3 is going to move it to the left 3. So it's going to move it up 4 and to the left 3. So there's my point. Okay. So my vertex, instead of being at 0, 0, it's going to be up 3. So there is my vertex right there. So my vertex is going to be at the point negative 3. Again, remember, it's negative h. Okay. So my vertex is going to be at the point negative 3, 4. So my vertex is going to be at the point negative 3, 4. So there's my vertex right there. Let's call it V. It's going to be point negative 3, 4. Just be quiet, you're fine. Okay, negative 3, 4. Okay, so now if we go and we graph this, to help us get an idea on how it's going to graph, we can look at this negative 2 here out front. And I can tell that from the negative 2, the 2 is going to do a vertical stretch. So this is going to stretch it. Again, so it's going to be skinny because it's vertically stretching it. That negative is that reflection. Remember, that's the reflection in the... It's going to reflect it again down in the x-axis, reflection in the x-axis. So I know this is going to open down. Okay. To get an idea on how far down it's going to open, one thing is we can plot some points. Plug some x's in there, see what you get out for f of x's. Okay. So x, f of x, to see what that looks like. So let's go ahead, let's plot. Let's go ahead and let's plot on either side of my vertex. Because remember, my vertex here is where my axis of symmetry is going to be. So we could also write the equation for my axis of symmetry. So this is going to be symmetric about that line because the axis of symmetry always goes through my vertex. The equation of that line is going to be x equals, in this case, x equals negative 3. Because again, your axis of symmetry is always x equals h. My h here is that negative 3, because again, remember, it's negative h. Okay. So x equals negative 3. So then it's going to be symmetric about this. So it's going to open around here. Just get an idea on how wide it is. Let's go ahead and let's just plot a point on either side. So here, let's figure out what's happening here at negative 2. So let's plug in a negative 2 into this function. So I'm going to take negative 2 times negative 2 plus 3 squared and add 4. And when I get out, negative 2 plus 3 is 1. 1 squared is 1 times negative 2 is negative 2 plus 4 is 2. So I have the point negative 2, 2. So then using symmetry, I know I'm also going to have the same point on the other side. So I know it's going to look like that. Okay, so we've got a point on the other side. So label the vertex, there's our vertex. Label the axis of symmetry, which we have. The axis, so this is my axis of symmetry. Is at x equals negative 3. So we graphed it. We'd labeled the vertex and the axis of symmetry. Okay, we're done. Okay. All right, so but this is when it gives you the equation in vertex form. Okay. We don't always get the equation in vertex form. Actually, most often quadratics are written in standard form. Okay, standard form looks like this. F of x equals ax squared plus bx plus c. An example of a function in standard form. G of x, 2x squared plus 3x plus 1. Okay. The reason it tends to be written like this most often is it's shorter. That's the only reason, because standard form is actually not useful at all. I can't tell what the vertex is. I can't tell how it's shifting, left, right, up, down. I can't tell anything from this. The only thing I can tell is this first term does determine whether it opens up or down. That's it. That's all it does. That 2 out in front determines whether this thing is going to open up or open down. And gives me kind of an idea on the stretch. But I don't even know for sure exactly what kind of stretch it is. Okay, so vertex form, standard form is not useful at all. It's useless, standard form. Okay, but we can actually, vertex form can actually be written as standard form. Okay, pretty straightforward. Okay, so let's go ahead and let's rewrite this vertex form in standard form by expanding it. So what I'm going to do is I'm going to multiply this out using my h's and k's. Okay, it's going to be a lot of algebra. Don't worry, you will not have to do this on your own. Okay, we're going somewhere with this process. Okay, by the end of this process, we'll be able to use standard form to give us some information. Okay, so first things first, I'm going to expand vertex form. So I'm going to take this x minus h and multiply it times itself. So now I'm going to distribute out this x minus h. So I've still got my a out front. Times, let's distribute out the x minus h. So I need to take x times x, which is x to the second. X times negative h, that would be negative hx. Okay, now negative h times x, that'd be another negative hx. And then negative h times negative h is negative h to the second. Oh, so positive. Negative times negative, positive h to the second. Okay, and then we have our plus k out front. Okay. All right, we put together like terms. We have 2 of those, so we have still an a, x squared, minus 2hx, plus h to the second, plus, okay, on this side. Okay, and now let's distribute the a in. So we'd have a, x to the second, minus 2ahx, plus a, h to the second, plus k. Alrighty, so now if we go ahead and look at where our x is at, there's an x there, there's an x there, this has no x. So if we look at standard form is, again, ax squared plus bx plus c. So I'm looking for that a, what's multiplied in front of my x squared, the b, what's multiplied in front of my x, and my c, what's my constant that doesn't have an x on it. If we look at this, my a is, again, still my a, still in front of my x squared. So there's my a. Okay. What's multiplied in front of my constant? Sorry, in front of my x, not my constant. What's multiplied in front of my x? Negative 2ah. So that's my b. So this is still my a, and then this doesn't have any x's at all. That's my c. Okay. So from this, we can see my b comes from the negative 2ah. So my b in standard form, is equal to negative 2ah in vertex form. My a in standard form is just the a in my vertex form, because my a is the same as a. And my c in standard form is ah squared plus k in my vertex form. You might be like, okay, why in the heck does that even matter? Why do I even care? Well, why you care is you can actually then get some information from your standard form. Okay? From this. So, if I was to then take this equation here, this one right here, and solve it for h, it would be dividing both sides by negative 2a. So then my h is equal to negative b over 2a. How that is helpful is my vertex, again, remember from vertex form, is at the point hk. So if I don't have it in vertex form, I can get my vertex by doing negative b over 2a instead. Where my b is here, my 2a is there. Okay, so let's go ahead and let's compile all that bits of information. Okay, so if I have a parabola, but they give me the equation in standard form. Okay. First of all, if this a is positive, so if a is positive, greater than 0, then it's going to look like this. If a is positive, it's going to open up. Okay, it's going to open up like that. Okay, and its vertex, then, its vertex, instead of hk, I can't use hk because I don't know h and k, but I know the x-coordinate of the vertex from over here is going to be at negative b over 2a. And then to find the y-coordinate of my vertex, I just plug that into here. I take f of negative b over 2a to find my y-coordinate. Okay. If a is less than 0, if it's a negative, then it's going to look like this. It's going to open down. But everything else is the same. The vertex is still going to be at the point negative b over 2a, f of negative b over 2a. Okay. So then now I can actually get some information from standard form. Really, all you need to remember is that the vertex is at negative b over 2a. Okay. All right, so let's go ahead and let's look at here example 2. Okay, first of all, Let's look at my A in front of here. My A is positive. This tells me this is going to open up. Okay, it's going to open up. Okay, so now we need to find the vertex, label the vertex, the axis of symmetry, and graph it. Okay, so the one bummer, since it's in standard form, I can't just use HK, but I know the vertex is going to be at negative B over 2A. So I just need to find my negative B and put it over 2A. Again, there's my A, here's my B, here's my C. And I'm going to write this as plus and negative so it keeps my B, my negative, on where it needs to be. So I need to take the negative of B, well, B is negative 6, over 2A. My A is 3. So my vertex is going to be at negative negative 6, so 6 over 2 times 3 is 6. So my vertex is going to be at the ordered pair 1. Negative 6 over 6 is 1. And then now to find the other coordinate, I just need to put 1 into this function. So I need to find f of 1. So 3 times 1 squared minus 6 times 1 plus 1. So 3 minus 6 plus 1. So 3 minus 6, negative 3 plus 1. So negative 2. So my vertex is at negative 2. So 1, negative 2. So over 1, down 2. There's my new vertex. I know it's going to open up, so it's going to open like that. So there's my vertex. 1, negative 2. My axis of symmetry, again, goes through my vertex. It's going to look like that. So there's my axis. The equation for my axis is x equals, again, my h, x equals 1. That's the equation of that one, x equals 1. I know it's going to open up, so now I just need to do a point on either side. How about let's try 0. Let's put a 0 in this, so we're going to find f of 0 so I can get another ordered pair. So when I put a 0 into that, I'd have 3 times 0 squared plus minus 6 times 0 plus 1. So I get 0 minus 0 plus 1. So f of 0 is 1. So I'll have the ordered pair 0, 1. Using symmetry, then, it would be the same on the other side. So it's going to look like that. So we've graphed it, we've labeled the vertex, and we found our axis of symmetry. Okay. Finding the minimum or maximum value. We haven't talked about minimum or maximum value yet. The minimum or maximum value is the biggest or smallest value you can get out of the function. So the minimum and maximum values are your output. What's the smallest or the biggest I can get out? Okay, so if we come back up here to our properties of graphs, if we look at one that opens up, if we see here, these go up for forever. So if we're looking at the outputs, okay, if we're looking at the things we get out, that's the y values. So if we look here, my y values are going to keep going up and up and up and up and up because I'll keep getting y values all the way up here for forever. But I can only go down so far. My minimum y value is down here. This is the smallest y value I can get. So what's nice about minimum and maximum of a quadratic, the minimum and maximum occur at the vertex. So my minimum value there, so one that opens up will have a minimum. My minimum is going to be the y coordinate of my vertex. Okay. One that opens down is going to have here, this one is going to have a maximum. And again, that maximum is going to occur at the y coordinate of my vertex because that's the highest I can get out. So to find the minimum or maximum value, first you need to determine, does it open up? Does it open down? Because if it opens up, it'll have a minimum. If it opens down, it will have a maximum. And then you just need to find the vertex. Okay. So to find the minimum and maximum values, again, here's my function right there. Okay, does it open up or does it open down? Well, let's look at that A. My A is positive 1/2. So since it's positive, it tells me it's going to open up. So I know it's going to have a minimum. So it's going to have a minimum. So to find that minimum, all I need to do is find the vertex first. So let's find the vertex. Again, the vertex occurs at negative b over 2a. So there's my a, there's my b, there's my c. So I want the negative of b. Well, the b is negative 2, so if I take the opposite, that's going to be positive 2, over 2 times my a, which my a is 1/2. So it'd be 2 over 1, which is just 2. So my vertex is going to occur at the point 2 something. So to find what that something is, I need to put the 2 in that function. So I need to find what f of 2 is. Let's put a 2 in that. So 1/2 times 2 squared minus 2 times 2 minus 1. Okay, so we'd have 1/2 times 4 minus 4 minus 1. Times 4 is 2 minus 4 minus 1. 2 minus 4 is negative 2 minus 1, which gives me negative 3. 2, negative 3. So I know I'm going to have a minimum at negative 3. That's the smallest this graph is ever going to be, meaning I can't put anything in it and get out something that's smaller than negative 3. So we found the minimum. It has a minimum. It says describe the domain and the range. So my domain, again, is what numbers I can put in. Again, remember, domains are the numbers I put in. The ranges are the numbers you get out. Well, a parabola's domain is going to be all real numbers because I can put anything into this that I want. I can put a 5, I can put an 8, I can put a negative 7. So my domain is going to be all real numbers. And we use all real numbers so often that we actually have a shortcut for it. It's an R with 2 lines for the leg. So it's a double R, all real numbers. But the range in this case, what kind of things can I get out? Well, I can't get out anything smaller than a negative 3. Negative 3 is the smallest I can get. So I'm going to get out my f of x's, the stuff that I get out is all going to have to be bigger than negative 3. So it would have to be bigger than or equal to negative 3. So there's my range. My f of x is going to have to be bigger than or equal to negative 3. So f of x is greater than or equal to negative 3. That's my range. Okay, now we have one other thing we haven't talked about yet. Where's the function increasing? And where's the function decreasing? Okay, so let's go ahead and let's talk about increasing and decreasing back here on our graph. Decreasing, again, we know increasing means going up. Decreasing means going down. So to determine where a function is increasing or decreasing, the easiest way is to think about what the graph looks like. And as you're reading this graph from left to right, what's happening to the y's? Okay? If you notice here, my y's, as I go from left to right on this graph, what's happening? My y's are going down. So this is decreasing, okay, for all values here to the left of here my h. Again, this is my hk. This is h. Again, k for my vertex. So it's decreasing everywhere on that side, and it's increasing on the other side. So it's increasing over here, and let's change that. And let's write it like this. Let's turn the paper. And it's decreasing over here. So it's decreasing for all numbers on the left of h, and it's increasing on all numbers to the right of h. Okay, so since this one opens up, I know it's going to be decreasing for all numbers to the left of this 2. So for all x's that are less than 2, right? Because that would be to the left of 2, because this number here would be 2 for this particular parabola. And then it would be increasing for all numbers to the right of 2, x greater than 2. Okay. That's for opening up. For an opening down, it's just the other way around. Okay. We're actually increasing from there. So these are increasing. And then we're decreasing on the other side. We're decreasing there on the other side. Again, in this lesson, what are we doing? We're taking parabolas and we're breaking them down and finding all of the different pieces and ways of describing it. Okay. One thing to remember for our minimum and maximum values, we're looking for our outputs. Minimum and maximum are our outputs. We describe it in terms of our y values. Our minimum and maximum values, we're looking for our y values. Whereas increasing and decreasing, we describe using our x values. We use our x values to describe increasing and decreasing. Like here, my minimum was at -3. That's the y value of my vertex. My increasing and decreasing, I describe based on the x of my vertex. Okay. All right. Okay. The very last thing we need to talk about is intercept form. This is used very, very rarely. I just want to introduce you to it so you're familiar. Okay. What intercept form is it's another way of writing a quadratic function. Okay, it's another way of writing it. It's writing it in what we call factored form, where we have two factors multiplied times each other. Okay, and how this form is useful is x minus the p, x minus the q. P and the q are the x-intercepts. It's where this thing crosses the x-axis. So there's p, there's q. I know my parabola is going to cross the x-axis at P and at Q. Again, this A determines whether it opens up or down. Okay. So if A is positive, it's going to open up. So I know my parabola would look something like this, and the vertex occurs smack dab in the middle of P and Q. So there's my vertex. Again, it still has a HK. But again, you can't tell your H and K from this. The only reason intercept form is useful is you can very easily see those x-intercepts. Okay. So to find the vertex, what you need to do is find the point in the middle. This is smack dab between P and Q. Okay, let's go ahead and let's look one in vertex form. Okay, so here we want to graph f of x equals -2, x plus 3, x minus 1. So I know this is going to have intercepts at -3. Again, remember it's x minus p, x minus q. We'll get into more detail on why it's minus later on. And then 1. So this is going to cross my x-axis at -3 and 1. So I know my parabola is going to cross there. So it's going to look like that or like this. Okay. Now let's look at my A here, determine whether it opens up or down. My A is negative, so it's going to open down. So I know it's going to go like this. And my vertex is going to be smack dab in between these two. So I need to find the point smack dab in between. So let's go over one each, over one more. So this is smack dab in between. So I know my vertex is going to occur at the point -1 something. I need to find what that other something is. So I'm going to go f of -1. Plug it in. So we'd have -2 times 2 times -2. -2 times 2, -4. So at 8. So it's my vertex is going to be at the point -1, 8. 5, 6, not enough room, 6, 7, 8. So my vertex is going to be up here. So here's my x-intercepts. My x-intercepts at the point 1, 0, -3, 0. My vertex is up here at the point 1, -1, 8. And again, my axis is that line that goes through the vertex. So my axis is at the point x equals -1. It's the equation of my axis. Okay, and then I don't even need to get another point to graph it because I know it's going to come down. Oop, that needs to go through that point. Come down and go through my intercepts. Okay. So there we graphed a function from its intercept form. Again, we'll practice a few more of those in class. You'll have some in practice. Okay, so now you have your turn. You have 1, 2, 3 your turn problems. I want you to attempt all 3. Get something started. Please work in pencil so we can erase. Okay, so do the your turn problems 1, 2, 3. Come to class ready to discuss.